Okay, welcome back to this next video in our measurement series, and we're going to be looking at today the idea of area. Now again, a lot of this stuff maybe you've seen before, but we're going to be sort of planning through it, try and do it pretty quickly. Okay, so our learning goal is still that you'll be able to calculate the area of quadrilaterals and circles, and you'll be able to calculate the area of just some given shape. Okay, right. So now we're going to be breaking into the second dimension. All right, so I want you to think, picture for a moment, get ourselves a Cartesian plane here. All right, so here's our x-axis and here's our y. So we've got this idea of like a point being 0 dimensions, okay? Because you can stand on it, you can't go anywhere. If we have a line, we now, joining 2 points, this is now, that's down in the first dimension. If you're standing on the line, you're able to move just along the x-axis, just in the x dimension, all right? But if we were to also extend this single dimension here up a certain amount by multiplying it by a certain amount of y here, we now get an area, okay? And now this area exists in 2 dimensions. It has an x-ness going this way, and it has a y-ness going up that way as well. Okay, and so that's sort of where multiplication comes from, creating arrays like that, and it's where we get our area, the idea of area here as well. And I want you, it's a good idea to think about it like that, that it's a dimension this way multiplied by a dimension in the other direction, and that's how we get our areas, because all of your areas formulas are going to have 2 numbers multiplied against each other somehow. All right, somewhere in the formula there'll be 2 numbers being multiplied because there are now 2 dimensions at work. Okay, all right. Now we can convert. Here's some key ideas. We can convert between different units of area. So you might have remembered when we looked at sort of converting between different units of measurement just in one dimension, between meters, kilometers, centimeters, etc. But we can also do the same thing between our units of area. Okay, so if we're going from kilometers to meters, okay, so there are more meters, like that when you go from 1 kilometer is 1,000 meters, right? So you're going to get bigger, so we need to multiply. And we're going this way. So we're going to be multiplying here, okay? But remember that you might recall that since there's 1,000 meters in a kilometer, there is 1,000 times 1,000 when we're going from kilometers squared to meters squared, okay? Because if you think about it, if we're going to draw a kilometer squared over here, right? So that means that there's going to be 1,000 meters going this way, and there'll be 1,000 meters going up this way. So that means 1,000 times 1,000, we have a million in here. A million square meters inside a square kilometer. So we multiply by 1,000 squared, okay, or by a million. All right, so writing 1,000 squared is actually probably a little easier. Okay, now same thing as when we're going from meters squared into centimeters squared. There's 100 centimeters in a meter, so we're going to be multiplying, and it's 100, but because it's in a square now, it's 100 squared. Okay, when we go back up from centimeters to meters, we divide because our numbers are going to be getting smaller. Okay, same deal when we go from meters squared up to kilometers squared, we're also going to be dividing. Okay, now another unit you might come across is this idea of hectares. Okay, so it's another unit of measurement, usually when we're measuring sort of land, and you might have heard maybe if they're about, you know, farm property has a certain amount of hectares of land. Sometimes if there's a big bushfire, they talk about the amount that has been burnt as a certain amount of hectares of land. Okay, so if we're going from meters out to hectares, okay, we're going to be dividing, and there are 10,000 hectares in a meter, 10,000 square meters in a hectare. All right, when we're going back down to meters squared, we're going to multiply by 10,000. Okay, kind of complicated up a little bit there, but it is a unit of measurement that you will see come around, so it's good to get used to it. Okay, all right, let's have a look at some formula for some common areas here. And I'm not sure, let me see if I have any do it there. Okay, here's some formulas just for some common areas. All right, so our square, where'd that millimeters squared come from? Up here probably. Okay. So let's just quickly talk about millimeters squared then. Hopefully you can recognize that millimeters squared, remember it was, when we go from centimeters, it's timesing by 10, and so it'll be by 10 squared. Okay. All right, and we divide when we're going back up. Okay, here's some formula for some of our common areas. So square, the area of a square is equal to length times the length, which is length squared. Now, some of you might have seen it as side squared, which is fine. So you'd write the area of a square is equal to side squared. Okay, let's just say the side length is 2 meters. Okay, therefore is equal to 2 squared, which is 4 meters squared. Okay, boom, done. Super easy. All right, so please don't forget that now that we've moved into area, our units have this squaredness here. Okay, so please don't forget that. All right, let's have a look at our rectangle. So area of a rectangle is, again, just 2 lengths multiplied. So however long it goes in this direction multiplied by however long it goes in this direction. So a length times a width, width, however you want to write it. Capitals is fine, doesn't really matter. And so if this was 7 meters and this was 4 meters, you would have that the area of that is equal to 7 times 4, which is 28 meters squared. Okay. All right, triangle, a little bit different, and I've sort of changed the formula maybe to the way you've written in the past. So we've got our triangle here, and the 2 measurements that we use for a triangle is the base, which is this distance here, and the height, which is this distance here. But it's a special kind of height. It is a height that is perpendicular, which means at right angles to the base. All right, doesn't matter how you measure it, as long as that height it goes from the base to the top and is perpendicular to the base. All right, and we have this half out the front here because a triangle, if you draw a rectangle around it, this triangle is half of the area of the whole rectangle. All right, so we have, if this height here was 3 meters and this base length here was 5 meters, we would have the area of a triangle equaling half base times height, perpendicular. Oops. So that's what that perpendicular means. Okay, you can write it like that or like this one here. So that equals half times 3 times 5, which is 7.5 meters squared. Okay. Lastly, this year you need to deal with composite shapes, okay, which is a shape that isn't necessarily got a perfect formula for it. Okay, and the way that you do these is you break the larger shape up into smaller pieces. Now, there's a couple of ways you can go about doing this one. So, for example, what you kind of ask yourself, what kind of shapes do I have? And then you want to kind of break it up into that. So if we look at it, we've got a rectangle maybe with a triangle that's been cut out of it. Or you could see it as a rectangle here with a square, another piece added here, and this triangle sort of added onto the side. Okay, the easiest way to go about this one though is by just taking the whole rectangle and then subtracting away this little piece of triangle. So you can either add all the bits you've got or take a larger shape and then take those smaller pieces out that you need to. All right, so what we're going to do is we will call this outside piece, the big rectangle that used to be there, that's going to be area 1, and this little piece here is going to be area 2. All right, so area 1 is equal to, it's the whole rectangle, so it will be 5 times 9, which is 45 meters squared, and area 2 is equal to, I've got 9, I hadn't even written a length up here. Let's just invent one then, because I'm a bit silly there. Let's make it 7 meters. Okay, so that means that this little piece on the end here is going to be 2 meters, And we've got half base times height, which is equal to half 2 times 3, which is 3 meters squared. Therefore, the total area is equal to 45. We should probably explain a bit more. Area 1 plus area 2, which is equal to 45 plus 3, which is 48 meters squared. Okay, so a bit of a long process, depends on how many different pieces you're going to make up with that one there. Okay, so again, sorry that it's getting a bit long, but I'm trying to sort of smash a lot of things together that maybe you've seen before, and hopefully you can digest them pretty quickly. Okay, thanks so much for watching, and I'll see you at school.